Hi, so welcome to today's video lesson, and today's video lesson we're going to be taking examples on how to solve problems involving acceleration, distance, time, and more specifically we call it velocity time graph or speed time graph as the case may be. So we have this example. A car starts from rest, so when you're solving a physics problem, you'd always read through the question to know exactly what you are required to do. A car starts from rest and accelerates uniformly until it reaches a velocity of 30 meters per second after 5 seconds. It travels with uniform velocity for 15 seconds and is then brought to rest in 10 seconds with a uniform retardation. Determine 1. The acceleration of the car, 2. The retardation, 3. The distance covered after 5 seconds, 4. The total distance covered. So we have about 4 questions to answer. So what the first thing you have to do is to sketch out the graph. That's the first thing. To sketch out the graph, you start with the vertical axis like this and then like this. So this is the time axis as measured in seconds, and this is the velocity or speed axis v, and it is measured in meter per second. Okay, then the question says a car starts from rest. So anytime you hear the word starts from rest and you're doing a VT graph, velocity time graph, it starts from origin. Starts from here. Okay, good. So the car starts from rest and accelerate. Accelerate means it has to go, the graph has to go like this. Let me change the color of that. That means the car has to go like this. Okay, but it has to be straight. Let me do that again. Okay, good. It accelerates to reach until it reaches a velocity of about 30 meters per second. So that means it has to get to 30 meters per second. So we are around here, 30. Then it travels with uniform velocity. That means it's not changing its velocity. That means basically it just moves on a straight line, not changing that same 30, just moving on that same 30. And remember that I did this acceleration for 5 seconds. Pardon me, I didn't put that. 5 seconds. Okay. Then it moves uniform for next 15 seconds. So the next 15 seconds, 15 plus 5 will give us 20. Okay, good. And then it's brought to rest. This is rest here. On this horizontal, this is rest. Okay. So it's brought down to rest in the next 10 seconds. Let me just use a lighter color. It's brought to rest in the next 10 seconds. The next seconds tells us that it is actually 30 because 10 plus 20 will give us 30. Okay, so you see this is the graph that explains this question we are given. Okay, so now the first question now says that we should find the acceleration. Now this is where the acceleration is going on here. Okay, good. So if I have to find the acceleration A, how do we do that? Now remember that acceleration is what? Acceleration is velocity, change in velocity over time. Abi? Good. What's the initial velocity? That's v minus u. That's final minus initial divided by time. So our A then would now be, what's our v? Final velocity. It starts at rest and stops at 30 degrees. So our final has to be 30 minus, so not degrees, meter per second, minus 0. That's where it starts from, origin, initial 0. Then divided by, how long did it take? 5. So that's A equals to 30 divided by 5, and that's A is equal to 30 divided by 5 is 6 meters per second. squared, that's the unit for acceleration, per second squared. So we've gotten that. Then second question asks us to find retardation. Retardation is the opposite of acceleration. Acceleration means when the speed is increasing. Retardation means when the speed is decreasing. So you see that this is retardation. Okay, so what's going on? So retardation is going to be negative of A. Okay, so how do I know? So let's see, look at this. So retardation, let's just say is A equals what? Where is it starting from? Starts from here, it starts reducing from here and it stops here. So retardation starts from here and stops here. So if it starts from here, then U will be 30. See, that's the initial speed, 30. And the final will be what? It stops here, 0. So that will be 0 minus, that's final, minus initial. Starts from 0, starts from 30 and end at 0. What was the time it took? 30 minus 20, that's 10. It's even in the question, they said it took, what is it? Retardation 10 seconds to brought to rest 10 seconds. Okay. Then that gives us 0 minus 30, that's minus 30. That's minus 30 divided by 10. And so the retardation is actually minus 3 meters per second squared. So that tells us that acceleration is actually decreasing. That's why you have this negative here. Minus 3 meters per second squared. Then we have the third question, the distance covered after 5 seconds. Distance covered after 5 seconds. Where's 5 seconds? So this is 5 seconds. So what's the distance covered after 5 seconds? Now, to find the distance covered, we said that in previous video, that you'd have to find the area under the curve. You have to find the area. So what's the area here? It's a triangle, right? A triangle. So we have a triangle. Okay, good. And in that triangle, what's the distance here to here? Is 5. And then the height here is what? See, that's 30 degrees. So here is 30 degrees. 30. So can we find the area under this curve? Can we find the area of this triangle? Remember, this is a right angle triangle, and the area of a right angle triangle is actually half base times height, and half times 5, which is the base times the height, is 30. And so 2 here 1, 2 here 15. Sorry, yes, 2 here 15. And so you have 5 times 15. So this distance covered is 5 times 15, and that gives us 75 meters. So the distance covered in the first 5 seconds is actually 75 meters. Okay, good. Then the last question says the total distance covered. What's the total distance covered? That means if you look at this whole traveling of this object, what shape does it look like? Looks like a trapezium. Exactly. It looks like a trapezium, isn't it? Good. And here you have your A, you have here to be your B, and here you have to be your H. Okay, and what's the area of a trapezium? What's the area? I don't think you should forget that. So the area of a trapezium is actually half A plus BH. So now what's going to be the distance covered? What's our A? This is our A. And what's the distance? So this is 5, this is 20. What's the distance here? That's A is equals to 15. here. So the distance covered has to be half into 15 plus, so these are B, that's our B. So let's go and check the VT graph to see what our B is. So from here to here is our B, and we see that 0, 5, then it added 15, that's 20, then it added 10, that's 30. So the total time is actually 30 seconds, and so that's our B, 30. Then what's the height? You see where the height is? Good. So what's the height? Or what is it? It's the same here. So the height here is 30 degrees. Sorry, I'm not saying 30 degrees. 30 meters per second. So that's the height. 30 meters per second. So you have 30. So I can do 2 here 1, 2 here 15. And so S equals to 15 plus 30. I have 45. 45 times 15. What I get is 45 times 15 is 665 meters. So that's what I get. So this is the total distance traveled, and that's total distance traveled. So you can actually split this into triangles, then rectangles, then triangles, and add it up together. You get the same answer. But it's better to actually use the area of the full shape. It makes your work easier. Okay, so we're going to take another example on this same kind of problem. So here we have this example. So the question looks kind of long, but it's actually very simple. Now the question says an object moves in a straight line from starting from rest. So actually I'm doing a VT graph, I'm actually doing a VT graph. So let me draw my, do that again. That's bent. Oh, okay, good. So this is my time in seconds, and this is my velocity in meters per second. Okay, let me write that again, meters per second. Okay, so starting from rest, it starts from here, the origin. There are 2 stages in this journey. They already told you that there are 2 stages. First, A, it gains speed uniformly. It gains speed. I'm starting from 0, begin to gain speed. It begins to gain speed. So that means the speed is increasing, going up, going up. Then what happens to it? Then for 2 seconds, then it attains a speed of 8 meters per second. 8 meters. 8 meters per second for how long? 2 seconds. Does that for 2 seconds. 2 seconds. Okay, good. B, then it continues with this speed, this same speed. That means it's not changing its speed, just continues for the next 1.5 seconds. So of course 1.5 plus 2, like we did in the previous example, is actually 3.5. 3.5. What's wrong with my pen? 3.5. Okay, good. Now the question says draw a sketch graph of the speed time. That's what we've just done. So this is I've answered that. Then find the acceleration in stage 1. In stage A, this is stage A, and this is stage B. Okay, so what's the acceleration here? Can we do that? Remember, the acceleration is actually what? Change in velocity. That's v minus u, final velocity minus initial velocity. And so that's the formula we're using. So how do we calculate for that? And so we're going to be saying A equals, what's our final? So this is our initial. It starts from origin and stops at 8. So that's going to be 8 minus 0 divided by, what's the time it takes? It takes 2 seconds. 2. And that's 8 divided by 4. And that's 2 meters per second Sorry, not what am I writing? It's 2. 8 divided by 2, and that's 4 meters per second squared. That's the acceleration. Then the second question says, find the acceleration in stage B. Acceleration in stage B. So what's acceleration? Same formula. A equals to this. Still using the same formula. So find now. It starts from here, right? And ends here. So that's is 8. Starts at 8 and ends at 8. 8 minus 8 divided by what's the time it took? Took them 1.5. I mean, because 3.5 minus 2 will give us 1.5. Took us 1.5, and that's 8 minus 8 is 0 divided by 1.5, and 0 divided by 1.5 is 0 meters per second. So it has no acceleration. So basically, if you have seen it from here, you know that there is no acceleration. That means it's not ascending. That means there's no change in the speed. So if there's no change in the speed, then it's not accelerating. So from here, I know that this straight line in a VT graph means that acceleration is 0. So anytime you see a straight line, a parallel line to the t-axis, when you see a parallel line to the t-axis, that means that there is no acceleration. And then the third question says that the total distance moved during the stage A and B. So what's the total distance traveled? So as you can see, what kind of shape is this? What is the area under this curve? So what's the area under this curve, if I may ask? What's the area under this curve? It looks like this. Isn't it? Yeah, it looks like that. So can we call this a trapezium? Yes, we can call this a trapezium. And this is going to be our A, this is going to be our B, and this is going to be our H. Okay, good. All right, so let's start. What's going to be our B? Our B is actually the total, and that 3.5. 3.5. Okay, good. What's our A? Our A is actually this minus this, so this subtracted from this, that's 1.5. Okay, good. Then so our A is 1.5. Then what's our H? The height. What's our H? That's the height. What's the height here? It starts from 0, that's 8. So H is 8. So can we go and put that into the formula for trapezium? So the formula for trapezium is actually, area is actually equal to half A plus BH. So the distance covered would be S equal to half. So what's our A? Our A is 1.5. 1.5 plus, what's our B? Our B is 3.5. Then what's our H? Our H is 8. 8. Okay, good. And so by calculation, I have half into 1.5 plus 4.5. I have multiplied by 5. Then multiplied by 8. 2 here, 1, 2 here, 4. So I'm left with total distance traveled now becomes 5 multiplied by 4. And that S equals total distance traveled is actually 20 meters. You get 20 meters. Or you could actually just find the area of a triangle. This is a triangle, and the area of this square or the rectangle. That's fine by you. It's your choice. You get the same answer. You still get 20 meters per second. All right. So when you are solving VT VT questions, always be calm to actually read through the questions and make sure that your parameters are actually in line. Velocity or speed is measured in meter per second. Acceleration is in meter per second squared. Time is in seconds. Except you are stated to do otherwise. Then distance is in meters, except you are stated to do otherwise, maybe like kilometers or miles. But standardly it's just meters, meter per second, time, seconds, and meter per second squared. Okay, good. Catch you in the next video.